How do you multiply fractions? Just straight across, right? Multiply straight across here and here, right? So 3 times 5 is what? 15, and 4 times 7 is 28. So what steps did we just take to do what we just did? Multiply straight across. Okay? How does it change when instead of having a fraction, I have a fraction? Does it change any at all? No, it doesn't, does it? I multiply straight across. 2x. Multiply straight across. Now, here's what I want you to be careful of. I don't want you to do too much work. Okay? I want you to say x minus 4 times x plus 1. And then stop. Because aren't I multiplying those two? Do I have to distribute and get everything exactly simplified? No, because what if I need to factor something in the numerator? Well, I need these factored already, don't I? Okay? So that's just the answer. Is it wrong if you multiply it out? No, but it's another step you don't have to do. Okay? Any questions about that one? Okay? Well, how is this example any different? Example number 2. How is this different? Oh, it's not a fraction? But isn't it a fraction? It's 2 over 1. So don't I still multiply straight across to get 8 over 9? Multiply straight across. So this is really 3 over 1, right? Now, I don't want you multiplying things like this, but should we multiply 3 times 8? Yeah, that's too easy to not, right? So 24 over x plus 6. Yeah? And then over here, I just put that whole thing over 1, right? So again, multiply straight across. 8 times x plus 1 over x plus 6. Now, the whole 8 thing right here, 8x plus 8, that's pretty easy to do. Most people can do that in their head, right? Should we do that? If you want. This is still the right answer. Okay? Let's see, where do I want to try to trick you? Oh, next. Okay, next is the trick. You ready? What do I do here? So I could, right? What would I get if I multiplied across? 4 over 36, right? What do you notice about 4 and 36? We could simplify, right? Well, what if I could make it easier on myself and simplify first? Couldn't I do that? How would I know what to do if I was simplifying first? Well, does the numerator and denominators have the same factor somewhere? Yeah, they're just in opposite fractions, right? Is it okay for me to simplify this 4 with this 4? Yes, I can. What is 4 divided by 4? So that becomes a 1 and that becomes a 1. Now when I multiply straight across, what do I get? 1 over 9. Wasn't that a lot easier? Okay, so technically it wasn't really a lot easier. It was easier, right? But if we'll simplify first in some of our problems, it makes it a lot easier. Okay? So what did I do? So we want to look for common factors and then multiply like we've been doing. Because if they have common factors, those are things I can simplify, right? So looking at this problem right here, what can I do? I could multiply straight across, or I could notice that both numerator and denominator have an x plus 3, right? Here's an x plus 3 here, here's an x plus 3 here. Now they both simplify to 1, don't they? Because x plus 3 divided by x plus 3 is just 1. So what do I end up with as my answer? 2x over x minus 1. Here is where I'm going to try to trick you. I gave you a warning, right? Okay. Isn't there something else I can simplify? Doesn't the numerator have an x and doesn't the denominator have an x? Can't I cross those x's out? If I can, I'm telling you right now, if I can also do this. I can also say 17 divided by 19. I can cancel out the ones. And I can cancel out this line right here because those are the same, and I get this as my answer. It's ridiculous, isn't it? That's absolutely ridiculous. You know very well I can't simplify 17 and 19 by crossing out the ones and by crossing out this bar on the 7 and the 9. You know that's ridiculous, right? Except that's what you're trying to do if you're trying to cancel out these x's. You're canceling out a part of a number. You can only simplify factors, things that are being multiplied together. Okay? I would have multiplied straight across and got 2x times x plus 1. I would have multiplied straight across and got x plus 1 times x plus 3. I could have simplified the x plus 3's because it's an x plus 3. Not because they both have an x and they both have a 3, but because the whole number x plus 3 is in the numerator and the whole number x plus 3 is in the denominator. Does that make sense? Because when you try to cancel these out, that's what you're doing. You look at me and laugh and say, that's ridiculous. But when you try to do that, I have to be honest, sometimes in my head I'm laughing because I see you doing this. Does that make sense? This is what it looks like to me when you try to cancel out the x's. I'm not going to laugh at you to your face, but maybe inside my head a little bit, just being honest. Okay? So I'm going to try to trick you sometimes by asking, should we cancel out these x's? And what are you going to say? You're going to say no, right? We can't do that. That's ridiculous. You could say that's ridiculous as long as you're not being rude to me, right? That's fine, because it is. It's ridiculous. We can't cancel out parts of numbers. We can cancel out factors of numbers. This x right here is a factor of 2x because it's 2 times x, right? And if there was like an x right here, x times x minus 1, I could totally cancel out those two x's because they're things that are being multiplied together. If it's being added or subtracted, that's a part of a number, and you can't just cancel it out. You can't just make it simplify to 1. Does that make sense? Okay, so let's look at the next problem. Problem number 4. What do you want to do? We should try to simplify first. What can I simplify? 15 and 5, right? Both of those two numbers are divisible by what? 5. And if I divide 5 by 5, I get 1. If I divide 5 into 15, I get 3. Well, that's different than this one, right? Okay. Is that it? Oh, so another thing that's different than the first example, right? What can I do? What can I do now? 4 and 6 are both divisible by 2, aren't they? So if I divide 4 by 2, what do I get? 2. And if I divide 6 by 2, what do I get? 3. Now what do I have left to do? Is there any other things I can simplify? Oh, there's 2 3's. Simplify those. Oh, they're both in the denominator. I can't do that, can I? I can only simplify if one is in the numerator and one is in the denominator. What if there's 1 in the numerator and 2 in the denominator? Can I cross all of them out? Just 1, right? Because I need something over itself to simplify to 1. Okay? So now what's left to do? Multiply. Straight across. 2 times 1, 3 times 3, 9. Does that make sense? So what steps did we take? Kind of the same as up here, right? We looked for common factors. And then we multiplied. So let's look at this rational expression. Why is it called a rational expression instead of a fraction? Isn't it just a fraction? Yes, but there are x's, especially x's in the denominator. That's what makes it a rational function as opposed to just a fraction or a rational expression, okay? So what should I do first? I need to factor, don't I? Remember when I very first taught you factoring, even though you saw it in Algebra 1, I had to just refresh your memory on factoring, right? But I said, guys, this is super important because we're going to keep using it the rest of the year. Well, now this is at least the second time, if not the third time, that we factored not in the factoring chapter, okay? So let's factor what we can. Can I factor x minus 3? No, that's as simplified as it can. There's not a greatest common factor, and I can't take it into two parts, can I? What can I factor? For sure I can factor this one, right? The x squared plus 9x plus 20. Well, my leading coefficient is 1, so that's good because I can do my shortcut, right? What multiplies to be 20 and adds to be 9? 5 and 4. So what I get is x plus 5 and x plus 4 instead of that. It's not gone, it's just that I've simplified what was there. Does that make sense? Can I simplify the x plus 5? What can I simplify x plus 5 to? Oh, with this one, I'm just talking about factoring, like unfactoring. I'm sorry. Sorry, I can't do that anything to that, right? Can I do anything to this? It has a greatest common factor, doesn't it? What is the greatest common factor between 2 and 6? 2. If I factor out of 2, what's left? X minus 3, right? So I've simplified the denominator of that fraction as well. So now what can I do with what is left? Tell me what you wanted to do with the x plus 5. Yeah, there's 1 in the denominator and 1 in the numerator. So they simplified a 1. Is anything else can simplify? X minus 3. So my answer is just 2 times x plus 4? That's my answer? Oh, absolutely, because we have 1s in the numerator, right? We can't just ignore those. 1 over 2 times x plus 4. Now, if I want to, can I write 1 over 2x plus 8? I can if I want to, but this is a perfectly acceptable answer right here. You okay with that? Any questions? So how are the last two examples different than the first 4? They are dividing, right? Do you remember what you have to do when you're dividing fractions? Can I remind you? Okay. So earlier when I asked the same question, they knew some words and the math that they were doing was right, but their vocabulary was not right. Okay, so I'm going to teach you the math and the vocabulary at the same time. Actually, not teach, just remind, because you know how to do this, you've just forgotten. Okay, which is okay. We all do, we all forget stuff sometimes. Is that fair? Okay, so what we're going to do is we're going to change this problem to a multiplication problem, because multiplication we already know how to do. We've already done 4 examples of it, right? But when we divide by a fraction, we're actually multiplying by the reciprocal. Okay, now what they said earlier was, well, you just flip it. Okay, well, if I say multiply by the reciprocal, I'm multiplying by the reciprocal. They were just saying flip it. I'm like, how do you know which one to flip? Because we're only flipping one, right? If we're going to use that kind of vocabulary, we're only flipping one. Which one do we flip? The second one, right? Whatever we're multiplying or dividing by, this one is the one we take the reciprocal of. So if we say we are multiplying by the reciprocal, we're multiplying by our second fraction, okay? And then once I have the reciprocal of my second fraction, then what do? Just straight across, just like we've been talking about up here, right? So I get what? 16 over 3. So multiply by the reciprocal. And in non-technical terms, we flip the second fraction. You okay with that? So this problem becomes what problem? I'm going to factor as I go because I don't want to lose any steps. Okay, so I change that to 2 times x plus 2 because I see that there's a greatest common factor of 2 right there, right? Over x plus 3 times the reciprocal of what I'm dividing by. So it's x minus 2 over 5. I took this one and just flipped it over. Now, is there anything I can simplify? What do some people want to try to simplify? The x minus 2 and x plus 2, right? So first of all, they have to be exactly the same to be able to simplify. Exactly, right? These couldn't simplify because one's a plus and one minus, but you're right. That's what some people try to do. And what's the other reason we can't simplify them? They're both in the numerator. Exactly. Okay, so what do I get as my answer for this one? If I can't simplify, I just multiply straight across. 2 times x plus 2 times x minus 2 over 5 times x plus 3. Got it? The bell's about to ring. Can I please tell you which ones to circle on your other page? So on the front of this other page, I want you to do 4, 6, and 8. 4, 6, and 8. And on the back of this page, I want you to do 2, 5, and 8. 2, 5, and 8. Okay? Now earlier they were looking at this and they were like, we didn't do any of these. Well, I kind of agree with that. Okay? I think you have the multiplying and dividing down. What I don't think you have down is the factoring and simplifying yet. So that's what these problems are trying to get you prepared for, so that it's when it's time to actually multiply and divide, you've got the factoring and simplifying down. So all that this worksheet is about is factoring and simplifying. I know that there's no multiplying and dividing, and that's okay. Okay, because I think you have a good understanding of multiplying and dividing. I need to make sure you can factor and simplify. Is that fair? Okay, have a great day.